This tiny component looking like a transistor, marking 95A. It is linear Hall effect sensor, miniature ratiometric sensor. It will sense the presence of magnetic field when any magnetic flux, either it is positive or negative gauzes, will reach in its surrounding. It will provide proportional signal. Its output is ratiometric. Supply voltage are divided by 2. Let's suppose 4.5 volt to 10 volt supply voltage. It will divide these voltage to create output offset. Let's discuss its specifications, its use, and we will test it. SS495A or 95A Hall effect sensor. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, subscribe it. If you want to watch my videos in future, press bell notification for all so that you will be notified for my future uploads. Hall effect sensor or Hall sensor or magnetic sensor. It is a solid state component. You can say it is an IC, integrated circuit. There is special chip that will sense the presence of any magnetic field, ratiometric, proportional output, linear sensor. 3-pin component. If its part number is facing to our side, pin 1 positive voltage, pin 2 ground, pin 3 output. Input voltage can be provided from 4.5 volt to 10.5 volt. It will sense minus 670 gauzes to plus 670 gauzes. This is center line. When there is no magnetic field, the output is, let's suppose we have 5 volt supply voltage, VCC voltage. The nominal output is 2.5 volt. Let me connect it here and we will see it practically. Pin 1 positive supply voltage. We will use 5 volts. Most of the time it is used in joysticks to sense positive side movement or negative side movement. The center point, center position is 0. That means virtual 0, 2.5 volt. If voltage will increase in one side, the movement is in one side. If voltage are dropping, that will indicate that movement is in reverse order. Here is output signal. We will take output between common and right out. I will set multimeter to voltage, DC voltage. Never test any Hall effect sensor using continuity or like a diode because it is integrated circuit. Always verify the part number and see its specification and then test it. Supply voltage are divided by 2. 5.1 volts, 2.56. That input supply voltage are divided by 2 when there is no magnetic field. It will measure the intensity of the magnetic field. When magnetic field, North Pole or South Pole will come closer to its face, it will change its output proportional to the magnetic flux. You can see the voltage are dropping now. When this magnet comes closer to its body, the voltage are 0. That means in this side. When negative gauzes, 670 gauzes, are closer to its body, its face, the voltage are dropped. Check again. If I am placing magnet in this side, the voltage are dropping. If I will change the face of this magnet, the voltage are increased. When magnetic lines are in positive side, the voltage are in positive side from its virtual point, from its center point, that is 2.5 volt. It is not 0, it is virtual 0 for its output section. When magnetic flux will in negative side, voltage will drop. In positive side, voltage will increase. Voltage dropped, voltage increased. Using this technique, you can test the Hall effect sensor very simply and perfectly. If its output is stuck high or low, that chip is damaged. We can see its output is increasing gradually. Depending on the distance from the magnet, the voltage are changing proportionally. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.